Hello, here is another video for section 2.3. This is an example of another kind of problem that comes up in this section, in some of the homework problems. It's not actually in the text of the section itself, but I'm throwing it in here to try to get you ready for some of these homework problems. Now, you might need to come back to this when you're working on the 2.3 homework. So, let's say that you work in a lab where you need some acid, which is a certain concentration, and you need a solution, meaning like a mixture of something in this case, which is not a solution as in a value of the variable that makes the equation true, but we're also going to need that kind of solution to find how to make this kind of acid solution. Anyways, we need 10 liters of a liquid that is 15% acid, and unfortunately, you only have a 10% acid solution and a 30% acid solution, and you're going to need to mix them together to combine the strengths to get somewhere in between 10 and 30%. So, how much of each should you use? Now, with any word problem, I think a good first step is to identify the quantities that the question is asking for and probably make a variable out of those. So, if it says how much of each should you use, let's let X be the quantity of 10% acid you're going to use, and let's let Y be the liters of the 30% solution you're going to use. So when you say this, X represents the amount of the combined water and acid, which will look like this if you were going to draw a picture of it. Of course, if it's a solution, you can't actually separate the acid from the rest of the water. It's all mixed together. But if it was possible to separate it out, you'd have 10% of this volume of X liters is pure acid. And the same is true with Y. It's just that that's going to be 30% of that stuff is pure acid. And this also shows the goal of combining them together into 10 liters of liquid total, 15% of which is pure acid. So I think this picture will help us understand how this all works here. Now that you have the variables, this kind of table is really helpful for setting it up. And I actually copied this table right from the problem set exercises from this section for you to see. So let's see, what can we fill in here? The liters here represents the total volume of the solution that you're talking about. So let's say the 10% one is going to go as the first solution here, and we said that the variable X represents the volume of that. And the second solution has Y liters in it. Now, when you combine these together into one big container, it's the total volume you're going to have is going to be supposed to be 10. So that actually will give you one of your equations you can use, because when you mix these two things together into one bigger container, the volume of the first one plus the volume of the second one needs to add up to 10 liters. So you can write that as X plus Y equals 10. So that's one equation. Now let's try to fill in the rest of this. The percent acid, let's write this as a decimal so that you can actually do arithmetic with it. So 10% really means the decimal 0.10, and the 30% really means 0.30. And the percentage in the combination is supposed to be 15%, which we're going to write as 0.15. Now, let's see what else we can do. We can now figure out the actual amount of acid, the number of liters of pure acid within each of the mixtures. So the way to get that is to say, if you take your volume of acid, the liters of the mixture of the solution, multiply that by the percentage of it that is acid, you'll get the liters of pure acid. So specifically here, if you do x times 10%, you will get 10% of x. So I'm going to multiply these to get 0.1x here. And then 30% of y, we multiply 30% times y to get the volume of pure acid there, which will be 0.3 times y. And now to get an expression for the amount of acid total, well, it's going to be the same thing. We can do 10 times 15%, or 15% of 10, to get 1.5. When you multiply those, that should be 1.5 liters. Now, to get this other equation, what we're going to say is we know that this volume of acid here is 0.1x, and this volume of pure acid is 0.3y. They get combined into this 1.5 liters here, that 15% of 10 liters. So that means if you're adding the volumes of acid here, we'll get 0.1x plus 0.3y equals 1.5. Now, this equation you can solve either with, or the system of equations is what we need to solve now. You can do that either with elimination or with substitution. I think because you already have x and y by themselves here, it will make it easier to do with substitution. So I'm going to take this equation and subtract x from both sides. So if you do x plus y minus x, that leaves you with just y on one side. That should equal 10 minus x on the other side of the equation. So that is now ready to be substituted in place for this y here. And that gives you an equation that looks like this. And I do want to point out that it's important to include parentheses around this to show that you're really multiplying 0.3 times this whole thing. If you leave the parentheses out, it might just look like 0.3 times 10 minus x. But it was 0.3 times y, and y includes the negative x as well as the 10, so that all needs to get multiplied there. So then I'll go through the steps to solve this. Distributed the 3 into the 10 and the negative x. It's important both of those get multiplied by 0.3. So I combine the like terms, the 0.1x and the minus 0.3x into this thing. Then when you subtract 3 from both sides, you get this. Now let's divide both sides by negative 0.2. Gives a result of 7.5. Now we haven't answered the question yet, partially because we still need to find y, and then we actually, if you have a word problem like this, you need to write a sentence and use units and everything. But we can find y quickly using this equation here. So I'm going to take this 7.5 and plug it into this x, so I can say that y is equal to 10 minus 7.5, which gives you y is 2.5. Okay, so that should be the values of x that solve this system of equations, but to actually answer the question, we need to remember what those represent. So y was the number of liters of 30% solution needed, and x was the liters of 10% solution needed. So to answer the question, you should write something like this. So next up, I want to do one example about going against a current or going against the wind in an airplane versus going with the wind, how you can solve something like that.